Hello, in this video we will look at implementation of boolean function using decoder. Depending on the type of decoded output corresponding to a particular input combination, we will have two cases. Case 1 is when the decoded output is active high, and case 2 is when the decoded output is active low. So what do we mean by active high and active low output? So this is the truth table of a 2 to 4 decoder. When the input combination is 0 0, the decoded output D0 is 1, and the rest of the decoded outputs D3, D2, D1 will be 0 in case of an active high output. So in case of active low output, when the input combination is 0 0, then decoded output D0 is 0 and rest of the decoded output D3, D2, D1 will be high. So similarly for 0 1, decoded output D1 will be 1 and others will be 0 in case of active high, and in case of active low, the decoded output for input combination 0 1 corresponds to D1 and D1 will be 0 and others will be active high. So we'll take up an example and see how to implement the function when the outputs are active high and active low. So this is case 1. We are given a function f, input variables are a, b, c, and the output f is 1 for minterm 0, 2, 3 and 7, and we are also given another function g whose input variables are also a, b, c, and the output g is 1 for minterm 1, 4, 6 and 7. So the first step is to identify the size of the decoder that we need to implement this function. Since there are 3 variables, we will need a 3 to 8 decoder. And 3 to 8 decoder will have 3 input lines A, B, C, 1 active low enable input, E bar, and 8 output lines. So in a decoder we know that each of the output line will correspond to a minterm. So this will be M0, M1, M2, M3, M4, M5, M6 and M7, and function f is 1 for minterm 0, 2, 3 and 7. So this is 0, 2, 3 and 7. So the output of this OR gate will be function f. And function g is 1 for minterms 1, 4, 6 and 7. So this is 1, this is 4, 6 and 7. So the output of this OR gate is G. Let us take the same example and see how do we solve it in case of an active low output. Case 2 is active low output. So we are given a function f dependent on input variable A, B, C, and the function f is 1 for minterm 0, 2, 3 and 7, and another function g is also dependent on input variables A, B, C, and function g is 1 for minterm 1, 4, 6, 7. So the first step is to identify the size of the decoder that we need to realize this. So since there are 3 input variables, we will need 3 to 8 decoder. So it will have 3 inputs A, B, C, one active low enable input E bar, and 8 active low output. So in case of an active low output, each of the output will correspond to a max term. So this will be M0 capital M, M1, M2, M3, M4, M5, M6 and M7. So in order to realize function f, we need minterm 0, 2, 3 and 7, whereas we have max term 0, 2, 3 and 7. So what we can do is, we can connect these 4 max term to a NAND gate whose output will give us a 1 in case any of the input combination for 0, 2, 3, 7 is given. So 0, 2, 3, and 7. So this is your function f of a comma b comma c, and for function g 1, 4, 6, 7. So this will be g of a comma b comma c. We can verify this if you want. See, for input combination 0, 0, 0, outputs will be 0, 1, 1, 1, 1, 1, 1, 1. So all the 4 inputs to this NAND gate is 1. So the output G will be 0, and one of the input to this NAND gate is 0. So the output F will be 1. And similarly, you can verify it for minterm 4. So it will be 1, 0, 0. So in that case, M4 will be 0 and all others will be 1. Then all the 4 inputs to this NAND gate is 1. So the function f will be 0, and M4 is connected to this NAND gate. So one of the input to this NAND gate is 0. So its output will be 1. Let me write it here. This was for 0, 0, 0, and this was for 1, 0, 0. Similarly, you can verify for other input combinations in C. Function f will be 1 for 0, 2, 3, 7, and function g will be 1 for 1, 4, 6 and 7. We'll study more about the decoders in the coming videos. Thank you.